Let's go with our second part of the review. Now, this one gave me trouble because I didn't read it using a graphing utility, and I tried to apply the differentiation process to this. Of course, it wouldn't work because I have uh, 0. At pi halves, cosine is 0. So we're going to use the table feature. And check as we did before using what it approaches. All right, so we're going to go to our calculator. Oops, sorry. There we go. Oh, did it too fast, didn't I? There we go. I'm going to clear all of my screen. I'm going to go to y equals and clear that. And I'm going to enter my function, which is 4x cosine x. And then I'm going to make sure my mode is in radians, and that'll work. And we did do this one in class, and it took us a while. And I had my personal calculator in a mess, so it caused a big problem. Let's see where the graph is. We can look and see that it is mainly continuous, and then we can go second calc and hit the value and enter second pi divided by 2 and get no response because it is not, oh, my mode is not, my window is not enough. So let me go to window, and I have it very, very small, if you remember. So I want to put this at 0, and then I'm going to go to pi halves. And now I will graph it. And I'll make this pi fourths. Oops. Okay. So I've got this guy going. All right. And oh, I should make it past that. So let me make this 3 pi fourths. There you go. So we can see the whole thing. Okay, so we've got some kind of issues right about here on this function, and because we're talking cosine, and we're going to double check that it does not exist. And it gives us a value of 0. And that's because it is 0. Sorry about that. This is, so we can find the derivative of it. Sorry, I made this hard. So we're going to use the formula for derivative. F of x minus f of pi fourths, pi halves, sorry, all divided by x minus pi halves. All right, so we're going to do the math, and we're going to have 4x cosine x minus 0 divided by x minus pi halves. All right, so that gives me, again, these, I forget to put the limit, but we understand it's a limit as x approaches pi halves. So I'm going to have 0 in my numerator, and in the denominator, I'm going to have x minus pi halves. And in this case, it's 0 in the top, so the answer is 0. I'm sorry about that, but that's as hard as it gets. find the slope. Well, slope we know is a change of y over the change of x, which is the same as a derivative of the function, the tangent line. So we have in our list of arsenal, we have that the slope, the tan slope, is the limit as x approaches some c of f of x minus f of c divided by x minus c. All right, so, and we have our point. So this is our f of c. Here we go. So we're going to have the limit as x approaches 4 of 2x squared plus x minus 3 minus 33 all over x minus 4. We're going to simplify that. And then we're going to factor it. And I have, in this case, it's 4 and 9, because I need an x. So this is 8. So it's going to be some form of 8 and 9. So this is going to be a 2x and an x. And this needs to be a minus, and this is a plus. These cancel. So I'm going to now place the limit in there. 8 plus 9 is 17. So my slope of tan is 17. Now I'm going to construct the line. Actually, the tangent line. And that is y equals m parenthesis x minus that x of 1 plus the y's of 1. 17 times x minus the 4 minus the 33. I'm sorry, plus 33. It's not a negative 33, sorry. Y equals 17x, and I'm going to do that 4 times the 17, and I'm going to get 68, plus the 33. So I'm going to do some simple simplification of the two numbers. I'm going to get a negative 5 and a 3, 35. And this is my tangent line. Given this is my tangent slope. Okay? We have another one. It's another quadratic. They're not going to get any harder than this. So we know that we need the slope of our tan, which is the limit as x approaches 1 of f of x minus f of 1 over x minus 1. All right, so I'm not going to put the limit all the time, but I'm going to put what I have. X squared plus 11x minus the 15 plus 3, because it's minus the negative 3, all over x minus 1. I'm going to simplify that. Well, to get a positive 11, I need a plus 12 times a negative 1 to get that 11. So I'm going to factor. So these cancel, and I'm going to find my slope. By dropping in 1, and it's 13. Well, now I'm going to do the equation of the tangent line. And I have y equals, in parenthesis, x minus x of 1 plus y's of 1. So I'm going to have a 13, x minus a 1 minus a 3, because the value of y is negative. And there you have it, my tangent line with a slope of this at point 1 and negative 3. All right. So here we have an explosion causes debris to rise vertically. And in this case, with the initial velocity of 144 feet per second. And so I have this moving function. Remember, anything with an S is a moving function. And so what I have here is going to be t equals 32. We're going to have our moving function as this, and the height of the debris above the ground, S of t, is in feet per second after the explosion. What is the instantaneous speed, which is a derivative, of the debris when it hits the ground? So our first step is how long before S of t hits the ground. All right, so that means that our S of t, our height, is 0. Okay, so we said 0 equals to negative 16t plus 144t. And I'm going to take out a factor, a negative 16t. And that's going to give me, this is a t squared, t minus 144. Okay. Oh, sorry. I divided by 16. And that's 9. But no, it's, what is that? I know it goes in there. Let's go with 144 divided by the 16. 9. Okay. That looks funny, doesn't it? Let me try the multiplication, make sure. 144. Okay. And now we set it to 0, so therefore t equals 0 for this guy, and t equals 9. Well, this is at the end of that item, so it's 9 seconds. So we now want the derivative, because we want the instantaneous, so we want the velocity. Of that. Here we go. So we know that's the limit as t approaches 9 seconds of f of x minus f of 9 divided by, x minus 9. All right. So we need f of 9. Actually, it's s, but we're going to do it up here. S of 9 equals negative 16 times 81 plus 144 times the 9. Now let's see what we get. So 16 times the 81 minus, no, that was a minus, sorry. Negative 16 times the 81, because it's 9 squared, plus 144 times the 9, and I get 0. All right, so I have a 0. And that's good too. So here we go. Just verifying that that is true. So our velocity in terms of t equals the limit as t approaches 9 of negative 16t squared plus the 144t minus the 0x minus 9. So I've got a negative 16t times t minus the 9 over x minus 9, and I'm multiplying by 9. And we have a negative 144. It's at the time that it met. Okay, and that's the velocity. The speed is the absolute value of it, so it would be 144. But I'll take the negative. That gets into Cal 1. Okay, so here we have a formula, and it is the volume in terms of radius is 4 pi radius squared. Describes the volume of a right circular cylinder. Okay, it's one of these guys. I did one of these in our class. This is 4, and this is my radius. Height 4 and a radius r. Find the instantaneous rate of change, that means derivative, of the volume with respect to r when r equals 9. Okay, leave it in terms of pi. All right, so we want the limit as r approaches 9 of f of x, v of x, v of r minus v of 9 over r minus 9. So we're going to take the 4 pi radius squared minus, and that's 9. Oops, sorry. So let me move this over here. Let me clear it. I'm going to have 4 times 9 squared. Okay, and I get 324 pi divided by r minus 9. I'm going to factor out a 4 pi. And that's going to leave me an r squared minus, and I'm going to divide this by the 4. 81. So now I'm going to factor it. And we'll cancel. And now we're going to put in r is 9. And stick that in the calculator. Is 72 pi. And that's the volume. Cubic something, cubic feet. Is a change. Now on this one, we're talking partitions, and we're talking left end and right end point, and we're talking 4 partitions. All right. So in the partition, we have to first go to y equals and enter the function. because we have a calculator that's powerful, we can do all of this more easily by using our calculator. Here we go. Now, I'm going to clear everything, go to my y equals. I'm going to hit clear. 3x squared minus 2. Okay. So, and we want 4 partitions from 1 to 4. So, we're going to go zoom 6 first to see what we have. Okay, we can see we have it right here, and it's pretty big, because if we go to 5, it's 25, it's 75. So we're going to hit our window, and we're going to go -2 on the domain, and we're going to go, and we're going to 5, so let's go to 6, and do a 1. And then on the minimum, let's go with a -3, just so we can see the x-axis, and go up to let's go up to 80 and do a scale of 10. All right, there we have it. Now remember, we start here and then go all the way to 5, which is right here. Now we're not doing the calculator, we're doing it by the partitions. So what we need, okay, if I have from 1 to 4, this is partition 1, 2, 3, and 4. So I've got 4 partitions. So now all I need to do is do left end and y end. And we're going to use our second calc feature value. X is 1, then y is 1. If x is 2, y is 10. If x is 3, y is 25. X is 4, y is 46. If x is 5, y is 73. So we know on the left end, and by the way, our delta x, the small movement, is 1. There's 1, 2, 3, and 4 partitions, and they're 1 in width. So left end, our area for left end is delta x f of 1 plus delta x f of 2 plus delta x f of 3 plus delta x f of 4. And we know that delta x is 1. So I'm left with 1 plus 10 plus 25 plus 46. So my area is going to be, I'm going to go on my home screen, 1 plus 10 plus 25 plus 46, 82 square units. Now we're going to do right end, which means that we don't include f of 1. We start with f of 2. So it's delta x f of 2 plus delta x f of 3 plus delta x f of 4 and delta x f of 5. Okay. So we know delta x is still 1, but here we're going to have 10 plus the 25 plus the 46 plus the 73. And we're going to do our calculator. (154) square units, if I entered everything correctly, and you'll double check with your calculator. And that's just absolutely horrible. All right, So that takes care of that. We have both answers, and you can see the disparity. There's a big change. Well, now we have this last example, and we're going to do the same thing, but this one is from the interval 0 to 4. And we're going to find the partition of 4 subdivisions equal n. Choose the endpoint, the left, and then the right, and then the graph. All right. So our first step, enter function in y equals on our calculator. All right, because we have a radical. All right, here we go. I'm going to clear everything, go to my y equals, clear that, and do second square root of x squared plus 1. All right, and now let's talk about our intervals. Now we're doing intervals is 0 to 4. So there's 4 partitions of delta x equals 1 again. Again, I'm not beating you to death on this one, so we're going to see how the graph looks. It's too small, so I've got to reduce my max over here to about 8. Let's do 8. Let's see what happens here. Oh yeah, that's good. Okay. So we're going to do a table. And we're doing 0, 1, 2, 3, and 4. Okay. Second calc value at 0, we get 1. At 2, we're going to do an approximation. We're going to do 4 decimal places. 2 decimal, 2, 3, 6, 1. And your eyes are better than mine. Oh, I jumped to 2. I forgot 1. I'll put that right here. Sorry. It's going to be 2, but maybe. I don't know. Let's do 1. 1.4142. I think I did in the classroom. I added an extra 1. My eyes are pretty bad. 3. For 3, it is 31623. And in 4, I have 4.1231. Close enough. Your eyes are better. Okay, for my A, it is area of left end. So I'm going to have delta x f of 0 plus delta x f of 1 plus delta x f of 2 plus delta x f of 3. Okay, so now I'm going to put in my values. Delta x is 1, so I'm going to have 1 plus 1.4142 plus 2.2361 plus 3.1623. We're going to do the calculator. and I get approximately 7.8126. All right, thereabouts. Now remember, my vision is bad, so some on the smallness of this calculator. Area of the right end is going to be starting here. So I'm going to have delta x f of 1 plus delta x f of 2 plus delta x f of 3 plus delta x f of 4. Okay, and I'm going to put in, this one starts at 1, so I don't have the first one. I have the 1.4142 plus 2.2361 plus 3.1623 plus 4.1231. Okay. And I get 10. All right, so somewhere in between is the true one. Well, the true one is the calculator. And we give it a command. We go second calc, which is that trace key, and we're going to choose number 7. And it's the integral f of x. So let's do that. But we have to graph it. So we're going to graph it. And we're going to go second calc, and we're going to go number 7. And we're going to go from 0 to 4. And we're going to get, oh, let me do it again. Second calc, I guess I didn't do it right. 0. And the upper limit is 4. And our area again, it's just kind of small, 92936 square units. And you can see it's in between. So that is what I am telling you is what we need to do. Uh, 92936. Yes, that's good. I can read it there because it's larger. Thank you for listening, and you get ready for this exam.